So yesterday in class we discussed how to draw Bohr models, and today we are going to take Bohr models one step further and talk about how to draw Lewis dot structures. Before we can talk about Lewis dot structures, we have to go back and talk about Bohr models for a second. So remember that with the Bohr model, one of the things that you were asked to do was you were asked to go ahead and identify the protons, neutrons, and electrons. And so when we knew that the element, in this case is aluminum, and its mass number was 27, we could go use the periodic table then to determine the atomic number. And because this is a neutral atom, and unless I tell you otherwise, it will be a neutral atom, you would take the atomic number, which in this case for aluminum happens to be 13, and that tells me the number of protons, but it also tells me the number of electrons because it's a neutral atom. And then when we want to figure out the number of neutrons, it's mass number minus protons. So in this case, it would be 27 minus 13, which is 27 minus 13 equals 14 neutrons. So when I go to draw my Lewis dot structure, or my Bohr model, I would take plus 13 and 14, and then I'm going to start placing electrons, and in the first energy level, or shell, we can only have 2, so that'd be 1, 2. My second energy level, I can have up to 8. So 1, 2, 3, 4, 5, 6, 7, 8. So 8 plus 2 is 10. And then I'm going to go ahead and add 3 more. 1, 2, 3. And kind of doesn't matter where you put them as long as they're spread apart. And so now what I've done is I've created the Bohr model for aluminum. So if I'm going to redraw that right down here, we said it was plus 13 and 14, and then we had all of these structures here, or electrons here. And so once we've drawn this, we can now start talking a little bit more about valence electrons. So valence electrons are, let's see, what color would I like to use? Purple would be fun. Okay, so valence electrons are the electrons that are in the outermost energy level of an atom. And the other thing that's important to note about valence electrons is that the most number of valence electrons that an atom can have is 8. So an atom can have up to 8 valence electrons. So in our model over here for aluminum, ALUMINUM, which was 27, mass number is 27. So in this particular structure, I'm going to look for the outermost energy level, which in this case is this guy right here, and I'm going to count the number of electrons that exist there. So it'd be 1, 2, 3. So the atom of aluminum has 3 valence electrons. I'm going to probably always write them as 3 capital V E with a minus because that will make things a little quicker. So that's how we determine an atom's number of valence electrons. that in the outermost energy level there were 3 valence electrons. So, and the reason why that's important is because when we're going to be asked to draw something called Lewis dot structures, and Lewis dot structures are a quick, visual representation of the valence shell of an atom. And there are a couple of steps that you would do when drawing a Lewis structure. So the steps to drawing a Lewis structure are: step 1, identify the number of valence electrons in an atom. Number of valence electrons in an atom. Step 2, write the element symbol. Step 3, start to add dots, which are going to represent electrons, around the element symbol, spreading them out evenly. So start to add dots, which are electrons, around the element symbol spreading them out evenly. And the last step, step 4, is you are only allowed to double up the dots when 4 electrons are already placed around the symbol. So only double up the dots only double up the dots when 4 electrons are placed around the element symbol. So in the case of aluminum, we already identified the number of valence electrons here is 3 valence electrons. So what I'm going to do is I'm going to start placing valence electrons around the elemental symbol of aluminum, spreading them out as far as I can. So that would look like this. Oops, that's not the right thing. So that would be 1, 2, 3. So I'm spreading them out very, very evenly. And now we've drawn the Lewis structure for aluminum. I've got a couple of examples here that I'd like to work with, or work through pretty quickly, so that we can go ahead and identify how things are going. So, according to the examples here, we're going to do carbon, nitrogen, and oxygen. And so carbon has an atomic number of 6. So I'm going to put 6 protons, and I'm going to put 6 electrons, and we know that it's mass number minus atomic number, so it's going to be 12 minus 6, which will give me 6 neutrons. And so in this case, I'm going to start with my plus 6 and my 6, and then I'm going to start doing my electrons, which is 1, 2, 3, 4, 5, 6. And we'll come back to that in a second. Let's take care of nitrogen, which is the atomic number is 7. So that tells me I have 7 protons. It tells me I have 7 electrons, and its mass number is 14. So it's going to be 14 minus 7 to give me 7 valence electrons, or 7 neutrons rather. So when I draw this structure, I'm going to have a plus 7. I'm going to have 7 neutrons, and then I'm going to have 1, 2, 3, 4, 5, 6, 7. Okay? And then with oxygen, the atomic number is 8. And so I know that tells me I have 8 protons, which means I also have 8 electrons. And my neutrons is mass number minus atomic number, or mass number minus protons. So it's going to be 16 minus 8, which will give me, in this case, 8. So I'm going to start with my 8 protons and my 8 neutrons, and then I'm going to start putting in my dots. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so now I'm going to go back and identify valence electrons. In the case of carbon, the outermost energy level happens to be this one. So this is my valence shell. And when I look in that one, I can see that I have 1, 2, 3, 4 valence electrons. So when I go to place them around the carbon symbol, it would go 1, 2, 3, 4. And that is the appropriate way to draw the Lewis structure for carbon. Now, in the case of nitrogen, its valence shell is this one as well. And when I look at it, I can see it has 1, 2, 3, 4, 5 valence electrons. So when I go to start drawing, it's going to go 1, 2, 3, 4, 5. And note, I didn't double them up until I had 4 electrons placed all the way around. And when you have 4 electrons placed all the way around, you tend to double them up instead of spread them out like you did in the Bohr model. And now for oxygen, the valence shell is still this one, and I can see that it has 6, 1, 2, 3, 4, 5, 6, 6 valence electrons. So when I go to draw this structure, I'm going to start on top, 2, 3, 4, 5, 6. So again, I doubled them up after I had 4 electrons spread out as far as I could. Now, the interesting thing about these 3 elements is that when I'm looking at the periodic table, they come right after each other in the same row. So carbon followed by nitrogen followed by oxygen. So the number of valence electrons for carbon is 4. The number of valence electrons for nitrogen is 5. The number of valence electrons for oxygen is 6. And we can predict that the number of valence electrons for fluorine is going to be 7. And the number of valence electrons for neon is going to be 8. So going across the periodic table, going from left to right, every element in the first column has 1 valence electron. Every element in the second column has 2 valence electrons. We skip the columns 3 through 12 and we go to column 13. 13 has 3 valence electrons, 14 has 4 valence electrons, 15 has 5 valence electrons, 16 has 6 valence electrons, 17 has 7 valence electrons, and 18 has 8 valence electrons. Hopefully you see that pattern. Okay, so your homework for the evening is not actually in the packet. It's going to be an assignment that I'm going to be handing you in class, which is the periodic table basics problem, and I'll explain a bit about that in class, but we needed to know Lewis dot structures before I could do that. So no homework other than the atom project. Have a good night.